Hi, my name is Mia Calderon, and we're going to do Project 3, Bills, Bills, Bills. So, I'm just going to transfer onto my iPad and we'll get started. Okay, so now that we're transferred over to the iPad, we're going to simply answer A through G. So, what we'll be doing first is A, so plot your data and then see if it's a good fit, predict your energy bill based off the average temperature. So I've already done this, and to make time go by faster. So what you're going to do, you're going to hit this plus right here. Here, why don't we just do this? We're going to go Desmos. You're going to hit this plus sign, hit table, then enter your graph simply right here. So what you're going to do is the X and the Y. So as you can see, I put it all here. Then you're going to get another, you're going to go second, and you're going to put in this Y1 squiggly mx1 plus b, so that way it's y equals mx plus b. Then you're going to get your scatter plot. So as you get your scatter plot, we're going to go here, and you're going to go, for example, the temperature was 87.07. The cost was $4.51. So that's what this table is determining. So we're going to go back up here. Can you predict or report? Can you predict your energy bill based off of the regression line? So the regression line is going up. So this is why I wrote this right here. It is going up. So you can tell it's a good fit based off of temperatures because the cost is going up and so is the temperature. Now for B, report the slope and intercept. So I wrote it right here. The slope is M, intercept is B, but if you go back on Desmos, right here, it's going to show you the M and the B. And that's going to be your slope and intercept. So now, see how far to the left do you think you can get accurate costs. So we're going to go back on the graph that we did. So if you go way too high, of course it's not going to be 200 outside. It's not going to be any higher than 1 in the hundreds. It's not going to be any higher than the hundreds. But if you go too low, it's not going to be correct because you're going to get a negative. So instead of $6, you're going to get negative $6. That's not going to make any sense too. So there's a certain amount where you can indicate physical significance to each of the, to get accurate costs. So now that we got A done, B, C, now we're going to look at temperatures in Las Vegas. So I already wrote them down. In June, it was 99. July, it was 76. August, 103. September, 95. So we're not going to focus on this one right now. We're just going to mainly focus on these ones because we're answering D. If you're wondering where I got them from, I looked it up. And we're going to look at the highs. So as you can see, it still matches up, 99, 100, and 5, so on. So then we're going to go here. If you can see, so I have the Y equals, and then I put the M right here, X, because we don't know the temperature, we're going to put right here yet, plus the B, so it's a negative, so I put the negative sign right here. Now what we're going to do, since we're going to focus on June first, we're going to plug this in right here. Then, from there, we're going to solve. So we're going to go to Desmos. And we're going to write down exactly what we put. So the M was 0.219512 times the 99 plus negative 14.5469. So we got 7.18. We're going to leave it at that. And that's the cost. So to save some time, I've done this beforehand. And for July, we're still going to plug this 76 right here. For July, we got 850. August, we got 806. And September, we got 631. So there we go. And that's how you answer. Does it seem like a realistic prediction? Yes, it does. Because if you look at these ones, they're not negative, so that's a good thing. They're still going to the same amount. So 99, if we look at the 99 right here, it's pretty high, but it's in the 70s. I mean, it's not 6, it's 7. So you could still tell that it matches up. It's realistic. Now, we're going to go to E. This is where it starts getting kind of tricky. So, for E, we have 57 for December. Now, if we plug 57 right here in Desmos, using the same X and B, the same slope and intercept, we get a negative 2.3. Now, that doesn't seem right because we have that negative right there. So, it wouldn't really seem realistic. Well, let's keep going to January and February. So, I got 1.59, but it's still the negative. February, negative 71 cents. Now, this doesn't seem realistic at all, does it? Because of these negatives, you're not going to owe 71 cents. No. Or, in fact, you're not going to owe negative 71 cents. So, for this one, yes, these ones... Here, let's kind of change this color. So, for these ones, yeah, they kind of made sense. These ones, not so much. They're not making sense at all. Now, for F, we're going to go to F now. And what other factors can affect your energy bill? Well, one, summer, fall, maybe. So different weather. So whether it rains, it snows, that can affect your energy bill. And also how much you use. So when you're in a regular, your own home, debate how much you use per day. That's if you use so much of your AC all day, that's just going to make your cost go up and up until instead of that $7, it's going to go to what? $200. Oh. So that's how your energy bill can go up. So lastly, we're going to go to G. How could you find a more accurate model? Well, of course, on your energy bill, if you go to your energy bill, that's how you find a more accurate cost. And of course, it's not just going to be $6. No, the cost is going to add up. So whatever you do, you're going to need a more accurate energy bill. Well, you can just look at your energy bill and determine how much you use from there. Or you can do your research and use the energy consumption equation. So, which this equation is E T O T power, and then the T D T. So of course I'm not fully capable of explaining this to you, but I can tell you what it is. So this equation defines the energy consumption during the time period of T to be the accurate cost of the power consumption function, power T, overall in the period. Or you can use the router energy consumption model, which is E equals E boost plus E work plus E haul. So, of course, you could do more research on this and how to solve and go from there. Or you could simply do what we all do and just look at your energy bill. From this, you could determine maybe you don't need to use so much. Maybe the cost can go down a little bit. But of course, in Las Vegas, we don't just pay $6. We actually pay $12.50 or something like that cents per kilowatt that we use. So just think, per kilowatt that we use 12, right? But that adds up. So per energy, per the AC, anything you use, lights, that's going to add up. So if you just have to think about the more accurate model, which you can use this, of course, but you can simply just look at your electric bill. I hope this helped. This is project 3, and yeah, it's complete.